Hello friends, welcome to Suresh Aggarwal's Mathematics Shortcuts. Another important video of divisibility rules. When we start studying the divisibility rules in class 6th, 7th, in the chapter of factors and multiples, we come across the rules of 2, 3, 4, 5, 8, 9, 10, 11. Have you ever wondered why we miss out on the rule of 7? If you have not noticed that, open the books now and check. Is the rule of divisibility of 7 given in class 7 or 8 books? It will not be found. There's a reason for that, and we are going to apply that particular important concept on various divisibility rules of numbers which are greater than 11, like numbers 13 and 17. Can you check whether a big number of 4 digits, 5 digits, 6 digits, even 7 digits is divisible by 13 or 17 or not? Difficult, right? So watch the entire video. You're going to learn something really useful which will help you in making divisibility rules of big prime numbers up to 99. So you can actually make two different rules for every prime number, and you can check the divisibility of huge numbers of 6 digits, 7 digits, even 10 digits using that divisibility rule. And you are going to complete that knowledge. What is the divisibility rule of 7? You will find out yourself. So friends, very important concept of divisibility rules. So before I take up the divisibility rules, I need to tell you the concept of osculators. Now this is something very special. If you study osculators, you are bound to master this topic of division and divisibility. So let me tell you what are osculators. See, whenever you are talking about 7, like I want to check whether a number is divisible by 7 or not, I want to multiply this number by a single digit number so that my answer ends either in 1, or the same number multiplied by a single digit number gives an answer ending in 9. Now we all know that 7 3 times is going to be 21, that ends in 1, and 7 times is 49, which ends in 9. So for every prime number you will have two single digits which will give you a product ending in 1 or ending in 9. Now this 21, if I subtract 1 from this, I will get exact number of tens, that is 20, right? And if I add 1 to this, I will get exact number of tens, that is 50. Now the osculators for the number 7 is, since we subtracted 1 here, so the osculator is negative, and how many tens are obtained? 2 tens, right? And therefore minus 2 is the osculator for 7. Now this is the first concept you should understand. Likewise, there is one more osculator for the same number 7. We added 1, so plus, and how many tens? 5 tens. So minus 2 and plus 5, they happen to be the osculators for the divisibility rule of 7. So you can frame two different divisibility rules for this number 7. Likewise, suppose you have a big number like 31. Now 31 1 times is going to give you 31, and when I subtract 1 from that, you get 30. Now since I subtracted 1, the osculator is negative, and since there are 3 tens, negative 3 happens to be the osculator for checking the divisibility of any number by 31. So I think finding the osculators is not a problem now, right? And once you know the osculators for any prime number, the divisibility rule is not going to be difficult at all. So now I am going to apply this concept of osculators to check divisibility of some numbers by 13 and by 17. Before I start that part, let me tell you about the amazing short tricks for quantitative aptitude ebook. Now this particular ebook will help you develop 10 times faster speed of calculations. It contains 24 chapters which have over 300 short tricks through which you can excel in your basic maths calculations. and very useful for all the school students starting from like class 5 and till the placement exams, quantitative aptitude. This finds applicability. Look at the number of exams we have mentioned here. In all these exams, you can excel, save time by using these special tricks which are going to make you a human calculator. This short tricks for quantitative aptitude ebook comes with a reasoning course combo. So as of now, we have an offer in which we will give you the combined combo of the short tricks and the reasoning. Reasoning has some videos also. So what do you have to do to get this? You have to just send me a message on WhatsApp. This is the WhatsApp number 9896369963. That is the WhatsApp number, and just send me a message. I'll tell you all the details of how to procure this amazing short tricks for quantitative aptitude ebook. Summer vacations are nearing, and I know most of the students are looking for something useful to do during those holidays. So go for this. This is going to be an amazing collection to your already existing skill set. Okay friends, so we have the concept of divisibility rule of 13. Now when I want to check whether a number is divisible by 13 or not, first thing I have to do is to find that what is the osculator for 13. So to find the osculator for 13, I have to multiply 13 by a single digit number to get me something ending in 1 or 9. So 13 ones are 13, no, it does not end in 1 or 9. 13 twos are 26, 13 threes are 39, right. So I got a number ending in 9. Similarly, 13 7 times will give you 91, which ends in 1. Now I will take the smaller number because that is easier to handle. So what is the osculator? Now 39 minus 1 plus 1 rather gives you 40, and so the osculator will be plus, and how many tens are here? This is 4. So plus 4 happens to be the osculator for 13. So I'll be using this osculator. Otherwise you can do 91 minus 1, that gives you 90. So minus 9 can also be the osculator, but I'll be using the smaller one, plus 4. That will make my task little bit easier and convenient. So what do we have to do here? So let's take a number which is already divisible by 13. So let's take 44278. 44278. Now I want to check. See, I have taken an example which is divisible by 13, so you already know that it is divisible by 13, okay? If you don't know and you have to check divisibility by 13, what are you going to do? Remember the osculator? Plus 4. So just separate out the unit digit, and from the remaining, see, the remaining number here is 4427. So what do you have to do with this? Plus 4, right? So plus 4 times the unit digit, 32. And now if you add them, you will get the number 4459. And now because 4459 is again difficult to identify whether it is divisible by 13 or not. So separate out the unit digit again, 445, the remaining number, plus 4 times this, 9 fours are 36. That will give you 481. And 481 again difficult to identify, so separate out the unit digit. 48 plus 4 times 1 is 4, and that gives me 52. And see, 52 actually is divisible by 13, right? And if this number is divisible by 13, then the whole number, that is 44278, is divisible by 13. Now still, if you don't know whether 52 goes into 13 or not, just separate out the unit digit, do it once more. 5 plus 4 times 2 is 8. Look at this, 5 plus 8 is 13, and obviously 13 is divisible by 13, right? Okay, let's take a number which is not divisible by 13. What about 1, 1, 3, 6, 7? Now I have taken this number which is not divisible by 13. So let's see if we follow the same procedure, will we get a number divisible by 13 or a 0? Let's check. So separate out the last digit. 1136 plus 4 times 7 is 28. So what do you get here? This is 1164. Separate out the last digit. 116 plus 4 times 4 is 16. So 132. And 132 means separate out the last digit. 13 plus 4 times 2 is 8. That is 21. And look at 21. It is not divisible by 13, right? And if this is not divisible by 13, the whole number 11367 is not divisible by 13. See, there are two oscullators, -9 and +4. I have used the smaller one because that is easier to handle. Now likewise, if the divisor is 17, now what happens when the divisor changes? So first thing is you have to find the osculator. Now 17 times 3 gives me 51. And if you subtract 1, you get 50. So the osculator is negative. And how many tens? 5 tens. So this is one of the oscullators. Although you can do 17 times 7 also. That will give you a number ending in 9. But that number will be bigger than 5. So I will be using the smaller osculator. Like this is 7 sevens are 49, 9 4 carry and 11, right? So if I add 1 to this, I get 120. So because I added 1, so plus. And how many tens are here? 12 tens. And so plus 12 is another osculator. So either you can use -5 osculator or you can use plus 12 osculator. But I'll be using the smaller one, and that's always easier to handle. So you have to do something which is easier. So I'll take a big number now. How about taking 6, 3, 1, 4, 8, 2? I want to check whether this number is divisible by 17 or not. So let's separate out the last digit. 6, 3, 1, 4, 8. The osculator is -5. So -5 times 2 is 10. And that gives me 6, 3, 1, 3, 8. Separate out the last digit. 6, 3, 1, 3 minus 5 times 8 is 40. So that gives me 6, 3, 1, 3 minus 40 will be like 3 minus 0 is 3. And then 31 minus 4 is 27 and then 6, right? Separate out the last digit. 627 minus 5 times 3 is 15. That gives you 612, right? Now separate out the last digit. 61 minus 5 times 2 is 10, which gives you 51. And look at 51. 51 is divisible by 17. 17 3 times is 51. And so this big number is actually divisible by 17. You can do it further if you still are not comfortable, okay? So you can separate out the last digit and do the step once more, and I'm sure you are going to find the answer as accurate as it gets. So I'll give you a big number like 1, 6, 7, 6, 9, 1, 5, 7. Can you check whether this big number is divisible by 17 or not? Please post your comments in the comment box here. Try using this method and let me know in the comments whether this concept of oscullators works well for all the prime numbers up to 99 or not. And if it does, do share this video with all your friends so that they can also learn this concept of oscullators, which is not given in the books. And especially mathematics teachers, this is for you. Teach your students the divisibility rule of 7 also now and complete that topic in class 7th itself. So friends, if you like this video, do share it and do comment. That is the most important thing, your comments that motivates the educators. All the best.